Have you ever wondered how computers process information? At the heart of it all is the concept of logic in computer architecture. This fundamental framework dictates how a computer processes and manipulates information. During our journey, we'll explore key components such as binary logic, logic gates, Boolean algebra, and combinational as well as sequential logic. These elements form the building blocks of computer systems. So let's dive into the fascinating world of binary logic, which forms the core of computer architecture. At the heart of all computers lies binary logic. This simple yet powerful system represents information using just two states, 0 and 1. These states correspond to the off and on states of electronic switches, forming the basis of digital computation. Now let's talk about logic gates. These are the fundamental building blocks that implement Boolean functions performing logical operations on binary inputs. Take the AND gate, for example. This gate will only output a 1 if both of its inputs are also 1. In contrast, the XOR or exclusive or gate outputs a 1 when the number of 1s in its inputs is odd. These gates, among others, are combined in various ways to create complex circuits that execute specific tasks. Now that we've got a grip on binary logic and logic gates, let's move on to the mathematical foundation of logic circuits, Boolean algebra. Boolean algebra is the mathematical language we use to express and analyze logic circuits. It's a system of operations that manipulate binary variables, those zeros and ones that form the core of computer architecture. Boolean algebra uses operators like AND, OR, and NOT to construct logical expressions. For instance, consider the Boolean expression A and B or C. This tells us that for the entire expression to be true, A must be true, and either B or C, or both, must be true. This is an important concept when building complex logical conditions and algorithms. Now let's shift gears and talk about the two types of logic in computer architecture, combinational and sequential. Combinational logic circuits generate outputs based solely on the current input. They don't have any memory of past inputs. On the other hand, sequential logic circuits incorporate memory elements, allowing them to consider past inputs in their operations. Let's take a flip-flop as an example of sequential logic. A flip-flop is a basic circuit that stores a single bit of binary information. It has two outputs, Q and Q, representing the true and complement states, respectively. These flip-flops are integral to constructing memory units and registers within a computer system. Understanding these principles of logic in computer architecture provides a solid foundation for future studies in computer science.